Hello friends, this is the third video in EDA series. Let's understand one more critical point before we go for hands-on exercise. So why do we care about how independent variables are distributed? The reason is simple, that the distribution of independent variables directly affects the validity of assumptions behind regression models, the accuracy of predictions, the interpretability of coefficients, and the need for transformations or feature engineering. Let me wrap up this for you. So first we cover assumptions of linear regression. The relationship between y and x is linear in the parameters a, b, c, and d. This means that a, b, c, and d can only be raised to the power of 1. In other words, you cannot have a square, b cube, c cube, c into d. Also, these values cannot be multiplied or divided by another regression parameter. So you cannot have something like c by b, a into d, and so on. This assumption is critical for a valid linear regression. Second assumption is that your x1, x2, and x3 cannot be random. In monthly expenses linear regression model, we predicted best fit line. So our line was y equals to b0 plus b0 x plus error term. The expected value of the error term is 0. So in mathematically, if you put it, the expected value of error term equals to 0. Any idea why? The regression line is chosen using ordinary least squares, OLS, so that the sum of residuals equals to 0. And that means the positive errors and negative errors cancel out. On average, the regression line is centered through the data. We can check this concept mathematically as well. So the residual was actually the difference between actual values and predicted values. So here we can see yi minus yi cap is nothing but your residual. By construction of OLS, you can see the sigma, so basically the addition of all such errors from I equals to 1 to n should be equal to 0. In other words, if I take average of the values, or basically the addition of all the errors, that should come 0. So then the question is, what if the error term, the expected value of error term is not 0? Then what would happen? So in that case, your best fit line will shift. Either it will shift down or it will shift up, because it has to get your error term, the sum of error terms, 0. Now let's understand another point here. The variance of error term is constant for all the observations, and this is called homoskedasticity. And if the variance of error term is not constant, then you will have heteroskedasticity in your data. So that means predictions are still unbiased, but confidence interval and hypothesis test become unreliable. The error term E is uncorrelated across observations. And the final one is the error term is normally distributed. And what does that mean? When you put the distribution of error terms, the mean will become 0. So these all were your assumptions behind regression models. So let's recap. So we check assumptions, what we just did. We handle skewed data. We need to understand that whether what kind of transformation is needed, whether you require log transformation or square root transformation. Then third point is the scale inputs properly, and that basically gives you whether you need to normalize the data. In other words, you need to standardize the data. Then you also need to see whether you spot any redundant features. So for an example, if you have grocery and milk both in your equation, maybe you need to think that, what if the milk is already part of grocery? The milk here is actually redundant feature. And then the last point is improve accuracy. So to improve accuracy of your model, you need to focus on feature engineering. So I think I will cover feature engineering in some other video because we need to probably with that I will also cover your log transformation and square root transformation. So thank you. I think this was the shortest video so far. We will next cover the hands-on exercise on how to do EDA, and which will be more of the practical or the implementation of what we learned in last 3 videos. So before you come to the hands-on exercise, please watch all these 3 videos